Yeah, started the recording. Go ahead.
Yeah. So yeah, just to get a benefit, I think me and Tushar joined the last call, but Ashwini was not there in the call. So that's to get the idea. We wanted to have a recheck on overall process. So we are segmented into. As I text you, actually, it will be preferably if you can showcase some of the system interfaces or at least the work what has been done, so that it will be more people will be able to correlate. But yeah, we can start from the your side and then let's see how it goes and we take it forward from there.
Yeah. Morning and good afternoon, everyone. Yeah, we can do that. Today is too short for a prepare the system, since we didn't communicate to the team, but what are we available in the system will show. So
Yeah, that's
the
fine.
agenda prereq is we'll start with the manufacturing piece, right?
Yeah,
And then go into source to pay and opportunity cash as the time permits.
yeah, that's fine.
All right, we have our team here, Joseph Alabay, whom you met earlier. He's the one from previous MF days. He will walk us through. We also have a number of our specialists on the call from STP, OTC, and Krishna, whom you know, I think he was we met you last time. He's our lead for the mining team based in Africa. Okay,
Hello.
with that, let's go to Joseph.
Yes, good morning. Good morning, all. I welcome us to the session. So I just proceed to share my screen now. Can you confirm? Can see my screen?
Yep, coming up. Yep.
Yeah, we can see it.
Okay. So we'll be looking at basically mining operations, which entails the planning and execution. That's minerals processing, and then we'll also look at quality management. Those are the two items we'll be looking at, and we will talk about the integration point between this particular process area. This is the production planning, and it's called PP. So in the course of this demonstration, I'll use the word PP, SAP PP, as SAP production planning, and SAP quality management. Those are the process areas within SAP that take care of minerals processing, basically. So I'll just to guide us, we have these few slides we've put together. I'll just I'll move on to the next slide. These are the items in terms of the agenda we'll be discussing. We will talk about enterprise structure, what it means in SAP, and how it relates to our operations. Then we'll talk about master data, process planning, mine ore processing, then quality management bits, and then we can take questions. And so I move on. If we have any questions, please just speak, because I might not see because I'm presenting. I might not see when you indicate that you want to speak. So if you have any questions, please just speak. Then I proceed to the first slide proper. So what is enterprise structure? So enterprise structure is the concept of SAP that maps our organization onto the SAP system. So we have our at the top level for us within production planning, it's a company code. So this company code is usually defined by the finance team. And we within production planning, we align or we adopt the company code that has been created. So Mika will be created a company code, at least a company code be created for the business, and then we would adopt that company code and proceed to define our plans within our own process area, and then the storage location. So what was the plan? Like I said, company code will be created by the finance team. So my colleagues, while they speak, if we have our finance colleague in the call, they'll discuss more about the company code. like I said, who adopt the company code that has been created. So what's the plant? Plant refers to where operations takes place, where the operations basically take place, mineral processing, where mineral processing takes place. Our mines, our sulfuric acid plants, also all of that will be created, map on the system as plants. And usually on the system, plants are alphanumeric, four characters alphanumeric. So in the course of the project implementation, we will define the plant codes. So once we execute transactions within the plant, because they've been assigned to the company code, automatically value postings place in the company code automatically based on the setup that would have been done. So for us, we'll be executing mineral processing transactions in terms of quantity. I mean, in tons, in volume, in whatever quantity units we will be consuming, we'll be producing, we'll be procuring. You understand? But of course, our colleagues in procurement will be procuring externally procured items, and to specify the plant code, which will have been defined. Like I said, automatically those postings will now take place in the GL account within this company code that these plants will have been assigned to. Then within the plant, we have, for example, we will have what we call storage locations. So these storage locations, they refer to areas within the plant where items are stored, areas within the plant. So valuation of materials within a plant is it's done at the level of the plant. Valuation is done at the level of the plant. But first, to enable us separate stock, for example, to enable us separate our cobalt powder from our copper cathode sheets. To enable us separate all the different materials, the reagents that I use, all of that is we do that based on storage location. So storage locations is a lower enterprise unit within the plant. So we'll see a graphical illustration of this to drive home the point. So we have at this level, top level, we have our company code. Like I said, we can now have plants beneath the company code. Then we can now have storage locations, raw material storage locations, where raw materials that are externally procured are stored, semi-finished material storage locations. Then we can also have finished goods storage location where our finished products, that's our sellable products like our copper and our cobalt, they are stored. So this storage location enables us to differentiate these particular materials. You understand? Basically, that's what it does. This is just, we have just gone ahead to bring out the enterprise structure that concerns this process area. But for us to see it holistically for all the process areas, this is a bigger picture of enterprise structure. So if we compare this graphic to what we saw earlier on, we will see that the plant is here, then our storage locations are beneath it. Then all that process areas, they also have their own enterprise structure. For example, if you look at this particular, you can see enterprise structure for sales-related enterprise structure. We would see enterprise structure for HR, or we see enterprise structure for materials management, what we call SAP MM, take care of inventory management, procurement. So we see the enterprise structure related. So all of these, they are all related or assigned to the company code, basically. And the company code, this is done within finance, assignment to the controlling area. This is a bigger picture of the enterprise structure. So SAP is actually integrated. What happens within production operations, that's minerals processing. Because this assignment has been done, then everything, all the postings, report can be done at the company code level. So this is just a bigger picture of the enterprise structure. Then I move on to master data. We said we'll look at after enterprise structure, master data. So
excuse me.
Any questions?
Can you go back on the
okay.
For this slide? Yeah, just a minute. Just give me a moment. Okay. So for every company code, I can have multiple plans, right?
Definitely, yes.
Yeah. As many as plans you need.
Okay, that's fine. Please go ahead.
Okay. So within the company code, we can decide to say while doing the project, we can decide to say our sulfuric acid plant, it's a different plant code from the solvent extraction and electrowinning plant, you can decide to have two different plants or 3 different plants. So you can actually have multiple plants in a company code. And a plant can only be assigned to one company code. Any plant we have can only be assigned to one company code. A plant cannot be assigned to two company codes. It must belong to only one company code. But
Yeah, that's correct.
multiple plants can belong to single company code. So those I think if I go back yeah. So you see here, if I just go back, I just went back a few steps, one slide or two. So a plant is assigned to a company code basically. So single or multiple plants can be assigned to only one company code. So a plant cannot be assigned to multiple company codes. Okay.
Just one small clarification. Even if I have multiple plants within the same company, say like even if their products are different, I'll be able to manage that, right?
Yes, yes. You will have to manage. Yes, we will be able to manage that. Yes, definitely. Yes.
You have multiple production lines. Okay, one is producing sulfuric acid, another is producing, copper or cobalt or any of these items. Okay, so we have two different production lines. Say like for multiple, if I would say, on one plant, there is a sulfuric acid, one is the copper, one is the cobalt. So I
Yes.
can have those multiple plants.
Definitely, yes. Yes, you can have those multiple plants within the same company. Yes. Okay.
Okay. So each would be a separate profit center for me. I
Yeah,
can have.
so we can have you can have within finance, that will be defined within finance. That is part of the setup that we done within finance. So each of them, the cobalt can be a different profit center from the copper for reporting purposes, for analysis and all of that in the future or on a daily basis.
Yeah, so I think to Ashwini's point, Ashwin, I think you're asking question is a plant also can be a profit center. Each plant can be a profit as well. I think that's
Exactly.
yeah.
Okay.
So it's very flexible and scalable system as for HANA, and you can define based on the choices you make, the business decisions you make within the Somika. You can define.
The reason why I'm saying is because the financial, the expenses and everything, they are maintained separately for each project center, profit center, sorry.
Correct. Yeah. That's how it works in SAP as well. Yeah.
Okay. Okay.
Any more questions around this before we move on to master data? Okay. For master data, these are the master data for SAP production planning and SAP quality management. So the first 5 we have the production planning related, and the other 3 we have in it. They are all management related. I'll just try and quickly describe each of them, what they mean. Our material master refers to the items that we procure, items that we produce, and the items that we sell. So those are material master. So each item will be created on the system as a material on the system. That's what we refer to as material master. So material master contains
Material master is common to on the company level, or it is on the plant level? How it is?
So for the material master, it's both. It's both. So the material master has what we call there are what we call basic. We'll see on the system. There's what we call the basic view that has general information. Things like unit of measure. That's common. Then if a particular material can sit in a particular plant, and there was plant A and sit in plant B, then we have the ability to maintain plant specific information for that particular material. So yes, it's both. Common information is kept in the material master, also plant specific information such as profit center, for example. So I can have one material that exist in the cobalt plant and the sulfuric acid plant. So the general information will be, for example, the unit of measure. Then the plant-specific information, profit center will differ.
So I have a reason. I have a question here. For when you say if I have a, if I have a common unit of measurement, one of the plant under the same company is using a particular material in ton, and another plant is using the same material in kg.
Yes.
Will that be possible?
Yeah.
Yes, to answer that question, I'll just say yes, or I'll just show SAP now to quickly answer that question. So these are materials on the system. These are materials on the system.
Yeah, can you show that, hey, Joseph, going to the system, show material master. So those are defined, Ashwini, based on each plant. Your unit of measure could be a different unit of measure based on the plant. One could be kilos, other could be, as you said, pounds, etc.
Yes, definitely, yes.
And just to add on to that, Ashwin, one more point is we can maintain alternate unit of measure. Let's say, probably
Yeah,
you
that's
can procure in kgs,
yeah.
probably you will sell in tons, right? Alternate unit of measure. There is a concept called alternate unit of measure. We can convert kgs into tons and vice versa. So for how many conversions you maintained, we can leverage that functionality in SAP and we can achieve that. Yes, we can do that.
That is, if it's in the same plant, there's a flexibility
Yeah.
there too.
Yes.
No,
Yes.
you're talking about when it is in the same plant. What I'm saying is,
Across the
say
plant.
for the reason I'm saying, I'll tell you. For one plant, it is a raw material. For another plant, it is a finished good.
Yeah.
Okay. So from the finished good, when it comes to another plant as a raw material, the UOM will change.
Correct. Yeah, that's fine because
Yes,
the
yes.
plant that produces the finished product is selling to the other plant, right? So you'll
Right.
have an intercompany transaction, Ashwini, in this case, intercompany.
Right.
You'll have intercompany
Right.
transfer to the second plant where it is consumed as a raw material.
Yeah.
It will be defined as a raw material and corresponding unit of measure for the raw material in that plant.
Okay, so the item will remain same.
Item will remain same. Yeah.
Correct.
You get changes the
And
form.
the unit of measurement, how will I take that?
It is there is a unit of measurement he'll show you. Go into that material and are you sharing the screen? Joseph?
Yes, can you still see my screen?
Yeah, we
Yeah,
can
I
see.
can.
Go ahead.
Okay.
Can you pick up and show the unit of
Yes,
material?
I'm trying to show one material that fits this particular scenario.
Mm-hmm. Can you go inside and show us, please?
Yes. So we have material, for example. These are plant-specific information. So I'll take a unit of measure for this, and I'll take.
Can you maximize your screen? I think it looks smaller.
Okay.
Maximize one of those buttons on the top. Mm-hmm. Yeah, the middle one.
Okay.
Yeah, thanks. Yeah, now we can see better.
Better, no?
Mm-hmm. Much better.
This is actually a copper cathode sheet, and like I was trying to explain, general information will be stored in these 1, 2, 3. General information will be stored in those 3 views. Then plant specific will now be stored in all of these other views. So if for example, I go to unit of measure.
तो मैंने हैंडओवर लिया था ना, वो SAP इंस्टॉल कैसे करवाता था, पूरा स्क्रीनशॉट का प्रिंट आउट लिया था, स्क्रीन देख के ऐसे नेक्स्ट बोलो अच्छा है,
I can't tell you.
ऐसा करके
Greg, are you on a mute? Talking to someone, looks like. Okay, go ahead, Joseph.
Okay, so this is the copper cathode sheet in one particular plant. So scenarios: one, within this same plant, or generally across, I can have this transaction. I can transact in this particular. If you look at this unit of measure, is each. Possible. I also want to transact in pallets. In pallets. So there are different functionalities I can use for that. I can come to additional data. Then I'll come to unit of measure here. Then I'll specify here that my alternate unit of measure will be pallets. Then of course the base unit of measure, this base unit of measure will be remain each. Then I'll specify the conversion factor from pallets. Okay. So that makes it possible for me to transact pallets in this particular for this particular material. Now, if it's in a different plant, if it's in a different plant, so I can just quickly, let me just quickly get to show that now. I'll just quickly do that right away. So plant IB01 is the first plant. Then our second plant will be plant, I just want to show in a different plant. Okay, EC01. Okay, so this is what I was trying to do on the other screen. If you can see my screen, so you can see that this particular material, copper cathode sheet, exists in plant IB01. This is a plant code. This column here is a plant code. So we can proceed to create this same material existing in another plant code, C01. This was what I was trying to do behind the scenes. So we can see that this material can exist in two different plants right away. Okay, great. Okay. So the material is now created in two different plants right away. So let's see when I run the report of my materials again, and I refresh this list, I remove this plant, I refresh this list, and I execute. We'll see that our copper cathode, and see now that copper cathode, it exists in plant EC01 as well as plant IB01, but it maintains the same material number. Same material number existing in two different plants. Same material number existing in copper cathode sheet existing in two different plants. So, okay. So that
the UM is also same.
Yes. It is same. So if in this particular plant, if in plant EC01, the direction is pellets.
No, but he's saying unit of measure, you need to change it. See, it says each in both the plants. Change it.
The base unit of measure will remain the same. This is the base unit of measure.
That is the reason I asked.
Yeah, base unit of measure will remain
because
for the plant specific measure. I will show where we can maintain that right away. I can maintain that quickly for sake of time. Let me just quickly show. So if I go to my unit of, I will show that here quickly. EC01.
Yeah, put a plant number. Yeah, it should be specific to plant unit of measure. Can you change that?
Unit of issue in this particular plant. This is example unit of issue. This is opportunity for me to maintain the unit of issue that differs here in this plant.
Unit of issue can be multiple also.
Yeah, exactly. So by default, the system will default this and can be multiple. Any
by default.
So if I want to
see, I'll give you a very simple example. Forget about the production side also, but production for us, even on the production side, it is equally important. Suppose I'll just give you a very simple example. We have when we go for a purchase of a grease, we buy it in drum. Okay. Yes. But when we issue the same material in our store, we issue it by gram or by some other unit of measurement. Okay, say for plate, again, say like we will have a size of a plate, but when we issue that material, it is either in weight, uh, or it can be some other unit of measurement. So in such instances,
I think I lost the discussion. So are you still there?
No,
Are you
one
still-
second. He'll be back. He'll be back. Hold on. Ashwini, you're on mute.
yeah, please there. Please see for sulfuric acid also. Probably it is all about the container, the size of the container which is getting filled up. But when it comes for consumption on the customer side or the client company, within the company, say like when it comes to another plant, then probably it is in liters or some secondary unit of measurement.
Okay. Yes, yes, it's fine. That is already the system can actually accommodate that. So that's what we see here. That's what we see here. We can see that these are two different plants. Can you hear me, sir? Can you hear me, sir?
Yeah, I'm able to hear you.
Okay. These are two different plants. And base unit of measure for consistency's sake, SAP makes the base unit of measure same. That's the base. But we can have different unit of measure per plant. So for example, whatever I maintain here, this will be like my sales unit. This is my sales unit. This is my opportunity for my production unit. Which should be different from my base unit of measure. Then I can transact in this. The same thing here. I can have different unit of measure here that differs from the example I just gave. So we can have different unit of measure transacting for this same material in different plants. I can proceed to quickly maintain that if you want to see that now quickly. Let me just quickly maintain that EC01. I'll just quickly maintain that on the system. I'm doing that on this screen now. So my unit of issue here, for example, can be pallets. So it's asking me to say for one pallet, we'll have 50 sheets, for example. Then I cannot proceed to transact in this particular plant in pallets. I save this. Then if I come here, if I can now do a different unit of measure for this particular plant, B01 quickly. Now this time around, I'm going to IB01 to do this. Plant now will now be not EC01 now, but IB01. And my unit of measure here, for example, would be the other time we use pallets. Now we can say we want to use pieces to differentiate. I can say we want to use pieces here. I'll save this. It's asking me. Then I can say here. I'll say one piece is one piece here. It's one.
For now, we can continue with this. We'll check it out. I mean, when we go in the detailed study of it, we'll work it out.
Okay.
Don't worry about this.
Okay. I just want to show that I'm already done showing that so that we see that this is ID01.
Don't worry about this.
That is it. Yeah, that is it in pieces here. But when we come here, it will show us in pallets. When we come here, it's showing me in pallets.
Okay.
You can see, and this pallet is in different plants. EC01. Why here it is IB01 in pieces. Okay, great. So let's proceed. Because of time, I'll just proceed to my
We can
slide.
proceed now.
So that's material master. So by material master, every item we produce, procure, and we sell, they are created as materials on the system. All the necessary information they are stored in the material master. So we have bill of material. Bill of material refers to the structure of our product. It tells me the components that go in as well as the output and their quantities. So it's just for so those quantities will be based on the based on the like our standard, based on the standard, basically that's bill of materials. Then when we do the actual production, basically that's when we record the actuals. This is relevant for planning and also for be able to compute our plan against the actual production, basically. Then we talk of resource. Resource refers to our processing lines. Our processing lines, basically, that's resource. We map them as our processing line, as a resource. All our processing lines will be mapped as resource. Then we move on to master recipe. Master recipe lists for me the sequence of operations: leaching operation, crushing operation, solvent extraction. So all of those operations will be mapped as master recipe. We will see on the further slide. So production version is necessary. It just uniquely identifies or names a particular combination of master recipe and bill of material together. That's the master data relevant for production. Because of the implementation, we'll have a team that will be focused on master data, and together we will try to pass the knowledge onto them so that we know what particular we'll determine our data requirement, basically in readiness for the project go live. Then we have our quality management related master data. These are the quality management related data, master data. So all the materials we analyze in the lab will be created as master inspection characteristics. All those that for a particular material, those items that we test to analyze will be created as inspection plan. This is not material specific, but this is material specific. Then code groups and selected set enables us to standardize how we record the result, basically. This enables standardization. We've gone ahead to show examples in the subsequent slide. That's why I was just trying to be a little bit quick. So this is material master. We'll have our finished products, which will be basically our cobalt and our copper. So every material, when creating a material, we need to specify a material type. So the material type for finished goods, our finished goods will be cobalt and our copper plates, basically. And they'll be managed on the system on a quantity basis and on a value basis. Quantity and value basis. Then we'll have our semi-finished. So all of those within the minerals processing, within the process, all of those materials that come in, those that go out of our operations, for example, our slurry or our GPLS, our raffinates, you understand, our copper pregnant solution, all of this on the system will be treated as semi-finished because these are not materials that we usually sell. These are materials that come out of the process and go back into the process. They'll all be treated as semi-finished materials. Then we move on to raw materials. Raw materials are the materials that we get externally from our suppliers, like reagents, flocculants. We have given some examples here. This list is not, these are just examples. This list is not exhaustive. During the course of the project, we will have an exhaustive list based on the engagement, interaction with colleagues from the business responsible for each of these process areas. So these are materials we buy from suppliers, basically, like limestone, flocculant, reagent, and all of that. So they'll be treated as raw materials. Then packaging materials, those are our jumbo bags or jute bags. Those are jumbo bags. Those will be created as, those we use for packing pallets. They will all be created as packaging materials on the system. And all of these will also be maintained on the quantity and value basis. Then we also have our mine ore. That's our mine ore, basically. That's our mine ore. That's the output from our mines. That's also be created on the system as a separate material on the system, and it will be managed on the quantity and value basis as well. Okay, then the next one that we have here is our process material. So these are just different material types that based on our experience and expertise that we've done previously for other customers, other businesses. That these are just examples of them. Questions at this stage before I move on to the next slide. Okay, there are no questions. So we mentioned another master data, which is resource. We said resource are the processing lines. So for these are also examples. We create, for example, the miner. This is from a previous engagement that we had. I'm sure our business will be very, very similar. This is not to say this is exactly 100% what we will do, but based on during the project implementation where we need to modify, we'll just leverage on what we have already. Where we need to add, we add. Where we need to deduct, we deduct. Where we need to make update, basically. Then we'll have our crusher, our miner, screener. Now, so all of these are usually created as resources on the system. Like I said, it's not exhaustive. We can also remove based on our own operations within Somica. These are some examples. These are other examples here. We have our leaching report power. We have our leaching tanks, the pre-leach tanks. We have our post-leaching tanks, counter-current CCD tanks, CCD tanks, then the solvent extractor, the stripper. So these are examples of resources, what we create as resources on the system. I'll move on to the next example we have here. And these are, we mentioned about the quality management master data. We said all the attributes we analyze on our products in the course of our minerals processing, is in course of our operations, and also in procurement. For example, we procure and we analyze in the lab. During the course of our operations, everything we analyze, all those attributes will be created on the system. These are some examples that we have done in the past. We created all of these in the past. So if we have additional ones, we include them in the list, and then they will be available to be analyzed, to be used for analysis on the system. Now, these are just master inspection characteristics set independently, not tied to any particular material. Now, where we not tie this, for example, say we analyze this group of MICs for a particular material. So that is what we now maintain in what we call inspection plan. That will be in the inspection plan for a particular material. It could be a raw material, it could be a semi-finished within our processing, or it could be for our finished product, that's our copper or cobalt. That will maintain in the inspection plan. I think that's that about the master data. This is just the last thing we want to mention about master data before we move on to the process itself. There's a concept called batch management. So batch management enables us to separate for a particular stock, for a particular stockpile. Then enables us to separate it in batches, uniquely identify separate quantities on the system. So that's what batch management. So this will help us to manage our what we call our ore grades. We use batch management to manage our ore grades. For example, we have different grades of ore, of mine ore. Batch management enables us to manage that. So I can maintain the different attributes, the different values for each particular that enables us to grade the ore, can maintain separately on the system for the same ore. So batch management enables us to do that. I will pause here and take questions.
Oh, Joseph, so this heap management, can we do by batch management in the SAP?
Yes, we can do by batch management on SAP. As long as we have those, so as long as we have those particular heaps, in terms of these, you have different attributes. If we have different attributes, that enables us to grade that ore into different grades, then we can use batch management to manage that, to maintain different characteristics values, basically, to maintain different characteristics values for the same ore, for the same mine ore. Does that answer the question? Yeah. Okay. Further questions before we move on to the next slide. Now we are moving on to we are moving on to a similar, something we have done, something we have mapped in the past. It might be similar to what we do at Somica, but it might not be that 100%, but it's basically what we have done for a similar company in the same line of business. This is the next slide that talks about it. I'm sure this particular slide might not be too clear, but let me bring a clearer, same thing, but a clearer slide, because this is very tiny. I think this might be, yes, this one will be clearer. It's the same slide, basically. I'll just we can see the same slide, but this single slide shows it or I'll put it in the presentation mode. I'm not sure if we can see it. Okay. I'm not sure if it's still very clear, but let me keep it.
The design of the I mean, the display is very small to understand.
So I'm trying to make it larger.
It's much better now. Yeah.
Better now.
Yeah, make it a little bit more bigger. The plus sign at the bottom. Expand it. Yeah, you're good. Good. Start explaining, and then you can move the cursors.
Okay.
Mhm.
So because here we're trying to show it from the beginning to
Sure.
the crushing and the leaching. So basically we start from our blasting in the mines, where we have now obtained our mine ore. So that mine ore will now come in into the crushing and leaching process we have put together. We'll just this together, crushing and leaching together. So the mine ore goes into a crushing operation. So everything in the box, the operations that we have that has been defined from a similar organization. So we have crushing operation. The mine ore is crushed. Then they are screened, and during the screening, water is injected to aid in the screening. Then if the
This flowchart, what you're sharing is in reference to any company that you have done it in DRC?
Yeah, yeah. It's a
yes,
schema.
yes.
Schema.
Okay. Okay.
So what comes out of the screening could either be fine or quartz. Then if it's a quartz, it still goes through series of operations to obtain the slurry ore. If it is fine, then the flocculants are added for it to be thickened. Then we obtain our slurry ore. So basically, this operation here and this operation, they do the same thing, but this handles the quartz ore, and this handles the fine ore to obtain our same slurry ore, which goes for pre-leaching operation. And for the pre-leaching operation, reagents are added. So these reagents are the examples of the raw materials that we get externally from procure. Reagents are added to the pre-leaching operation, and then the actual leaching takes place. And apart from reagents, acids are also used for the leaching operation, and that's the essence of our sulfuric acid plant. So it's possible also we also procure sulfuric acid, but basically we also have a substantial part of sulfuric acid being produced in the sulfuric acid plants. I'll just proceed to drag. Okay. Then at the end of the day, start the leaching operation. Using the after post leaching and then the CCD, that's a counter-current decantation. What we have is we'll get our tailings and our HGPLS. This HGPLS and low-grade PLS, they are the output of this particular crushing and leaching, and that consists what goes into this particular portion of that consists what goes into solvent extraction as well as electrowinning. So the HGPLS and LGPLS goes into the extraction stage, and we get our high-grade raffinates, and of course HGR, which is low-grade raffinate. Then those comes out. Then the stripping takes place, where spent solution is also reinjected into the stripping operation. Then what comes out as part of like a byproduct will be our pregnant electrolyte, copper pregnant electrolyte. Then winning takes place. That's where we now begin to obtain our copper sheets. Then we strap the copper sheets. We strap them using what part of our packaging materials. Then we transfer to. So this is like an as-is process that was defined. Like I said, it will be similar to what we do, but if there's a need to make updates to the operation, depending on what we have in our plant at Tomica, we make updates to this. So that's solvent extraction and electro winning. Then for our cobalt, this produces our copper sheet basically. Then for the cobalt powder, these are the operations that takes place. Low grade raffinate goes in, SO2 goes in, then neutralization, and all of these elements are removed. Then decantation takes place. Gypsum is obtained. Cobalt precipitation, then decantation again. Then we obtain our effluent and all of those treatment to the effluent. The effluent goes into where treatment happens to the effluent. Of course, something else is added, which is quicklime, and then the output is contained in the TSF pond. Then for the major operation for the cobalt, we have, after the solid liquid decantation and filtration, we have drying, and then after drying, we obtain our powder cobalt, where we bag in the big jute or jumbo bags. That's the last stage in this. Now, like I said earlier on, this tries to show all of the process that happens. So let's move on to the sulfuric acid. I'll just move on to the sulfuric acid. So this is sulfuric acid operations. You have solid sulfur, sodium hydroxide, and steam is injected into a melt the solid sulfur, and the filtration takes place as well. So it's a melting and filtration operation. Then that moves into the sulfur burner, where air is added, and all of that gases are added, like oxygen and nitrogen, they are added. Then have the waste heat boiler temperature reduction. Hydrazine is added, and all of these other water is also injected from the water plant. Understand? So then we have the passes that happens in the concept of the 4-pass converter. Then we have our absorption tower, and at the end of the day, we have our sulfuric acid obtained and stored in the sulfuric acid tanks. 1, 2, 3. So of course, ours can be more than 3 tanks or less than 3 tanks. But basically, this is the plant that produces the sulfuric acid that is used in leaching within our process. This is like a similar, like I said, it could be similar to what we do. I'm sure we can identify or relate with these operations that we see here for each of them. Let me pause here to take questions before we move on to the next slide. So this is what we have maintained. This is what we have maintained on SAP. This is what I can for the customer, basically. So it's what we maintain based on this as is. This is as is. When we say this as is, it means you tell us, based on the engagement, you tell us what you do. We document this, then in a process flow diagram like this, then we'll now maintain this on SAP. Updates will be made to this based on our operation. Questions?
So Joseph said on process side, it is like, okay, more or similar we have is clear. But how SAP, all the processes, can we map as it is in the SAP? One.
Yes,
And second, most of the process you covered from the production side, we also have mining operations. So from the mining operations side, have you covered any processes in the SAP?
So for mining operations, so like if you look at this slide, I think we have not the prerequisite mining operations obtain. That's where we get our mine ore, basically. So what we do for the mining itself is that we use what we call a process order to manage the estimated or the planned tonnage that we plan to mine for the months, for each mine. So we have a quantity that this is the plan. So we create that quantity in our order, what we call a process order. That quantity will be contained. Then on a daily basis, it could be, let me say periodically, it could be twice in a day, depending on business decision, to say this is the frequency. We'll now go back to that same process order to maintain the actual tonnage that has been the output of the mine. So we need to maintain, for example, I just mentioned 2 quantities. Plan for the months, for the period of 4 months. Then against that same process order, we go back on periodically, either on a daily basis or twice in a day or hourly, depending on how possible it is based on our operation to capture the output quantities. We'll now go back to that same process order to maintain or enter the actuals. So like I mentioned, for the month, there's a planned quantity, then periodically, maybe every 2 hours, or depending on how possible it is based on our operation, we'll go back to maintain the actuals.
Yeah, and how grade management and metal balances get done through the SAP is on from that angle, on particularly on the metal balancing or mass balancing side, SAP is having some capabilities. One and second is the grade management, like the overgrade quite fluctuating on day-to-day basis. So we have to make various blends, and then again we have to split the ore and grading and everything, sorting, grading we have to do. So there are one GRN, but one GRN having a multiple types of grades. So in that case, or they are partially feeding the material from one GRN, and we have to split according to the grade. So how from that angle, how SAP having some capabilities on the ore uh, grading one or ore management, like the blending, split, and the second is the mass and metal balancing from, let's say, from mining to the production.
Okay. So I'm trying to go to the next slide. Let me go to the next slide so I can use that to answer the question. So if you can still see my screen.
Yeah.
I'll minimize this. Okay. Yeah, so I'm using this particular slide to answer the question. So basically what we have here is the life cycle of a particular um, um, order. I said earlier on that we'll create a process order to contain the estimate or the planned quantity for the month, for the period of 1 month. So this planned order will be for the output, which is our ore. Then there's a step here, this particular step here, this that talks about order confirmation, goods issue, and goods receipt. So this is the GRN. Goods receipt here means the GRN. GRN of actuals against the order, referencing the same order. Actuals against referencing the same order. Now for the GRN, this GRN, so one possible way or one way that this has been managed is that for each GRN, we'll have, of course, what we call the material document number for each GRN, separate from the other GRNs. So also a batch number at point of GRN will be generated, separate batch will be generated. So those attributes for the particular ore that aids in grading will be maintained as a characteristics value at the point of GRN. Those attributes that categorize the ore grade will be maintained as characteristics value when we do GRN. Also, at this point, another functionality that enables us to manage the ore grading is that every GRN, once we do GRN, we use the quality management functionality, because an inspection lot will be generated automatically to also maintain or capture those grade-related attributes. We use the quality management functionality. So an inspection lot will be generated automatically. As we move on, we will see how those inspection lots are processed and the opportunity for us to maintain attributes for each particular GRN for the same mine ore. So three transactions happen for each, at every point in time for each time we go to a system. We post a GRN, and if there are components, if there are other materials that have been consumed, we consume.
Ashwini, you're talking to someone or are you talking to us? Thanks. Yeah, go ahead. Yes.
So if there are materials that have been consumed in the process, then we post a goods issue to consume those materials on the system. If there are for the output, we post a goods receipt, what you just described as GRN. Then this other confirmation is the opportunity for us to consume non-material activities like energy, like labor, for example. So we the system SAP S now gives us the opportunity to consume six different activity types. So these are the 3 different actuals that happen against the monthly process order. So is the question, is the query
Yeah,
answered?
so the question, Joseph, as you receive the product, the different grades, how do you manage that? That's the
So
question.
like I said, when we receive the product, and at that point of receiving, batch will be created automatically based on the setup, based on the configuration that will be done, a batch. Now for that batch, it gives us the opportunity to maintain the different grade attributes.
Gotcha.
But
Ashwini,
let's
did
say it's not a
go ahead.
batch. It's like, sometimes it's like from let's say hand to mouth situation, like where we mine and immediately we are feeding. So in that case, there is no time for the heap management. So in that case, actually, once we feed, and then we'll get to know the grade. And second is they sometimes just they do the basic checks like the QC is okay, grade is fine, and then they do. But actually, when we receive the material, it is in bulk, and only part of that material the plant people are getting taking to feed the plant. So it's not a complete batch or complete GRN. It's just like part of the material. But the QC is attached to the particular GRN, I would say, or particular batch. So in that case,
Yeah, so Tasha,
Basically, the material is
process,
used.
yeah, so there will be some process transformation when you go to SAP. I know what you're doing today, you're explaining, right? But SAP will transform some of these processes. It will require, if you have different grades, attributes, it will require a different batch going forward when you implement SAP.
so there is no alternate option other than batch.
So I remember I mentioned, apart from batch, we have when this happens on the system, automatically inspection logs. So there's that happens automatically behind the scene. There's an inspection log that is generated, and for that inspection log, it needs to be processed. So the processing of inspection log entails maintaining the result of analysis, all of those all grading analysis that we do in the lab. So we have to maintain for each of them, have to maintain the attribute, the result of our analysis. So that's why we have come here to say,
No,
material
definitely
relevant?
we have to maintain the attributes, but on what level we are maintaining? It is on the GRN level one, or it is on the batch level, or how?
It's so when the GRN happens, quantities coming to the system. Now that quantity that comes to the system, will have a batch. So we
so one GRN one
the batch
treated as a one
level.
batch. You are saying one GRN treating as a one batch in the
Yes.
let's say, okay. But actually, that is my point. When actually we are feeding, it's not like we are feeding complete batch, okay, on day-to-day basis. But we are producing on day-to-day basis. But one batch can be for month, or maybe a 2 years, because the operation of the mining in a such way that we stockpile some ore and some we actually feeding. So in
Yes.
that case, so in that case, like from the particular batch, we are taking only small part of the material, having a different grades, having a different QC, I will say.
Okay. So in terms of that, so that one batch that will be for like 1 year, at the point of the release of my process order, I will not, the setup that is done on the system is not to wait for the GRM before the batch is generated. At the point of release of process order, the batch number is generated. That batch will be for the period you have just specified, for 1 year, for 1.5 years, or that. Then we have also the opportunity here at this point, when we are doing goods received, for inspection lot to be generated for that same batch and process order, that same batch and process order. Inspection lot will differ for every GRN, there will be an inspection lot. This time around, it's not a different batch. It's the same batch, different inspection lot where we used to manage and maintain the ore grades.
So within batch also we can segregate the grades?
Yes. Using the lots, inspection lot functionality.
Okay. Okay. So that can be done even after making the GRN, right? Maybe after 2 months or 3 months, or as and when we are actually consuming that time.
Yes, that can be done at any point in time.
Okay, and the second is like the mass balance, or let's say metal balance also is one of the critical factor for the recovery, and where we are actually losing the metal. So to get to know, we have to do the metal balancing. From SAP side, how SAP will help us in the metal balancing?
In terms of material balancing, so without recording of quantities, material balancing will not be possible. So this type of goods issue is quantity related, where we actually document on SAP the actuals that have been consumed, either whether at the mine, at the crushing stage or leaching stage, basically based on the process we showed earlier on. So goods issue is done for materials and quantities. Goods receipt is done for materials and quantities. Then these are always done referencing the planned quantity we have specified in our process order. So based on that trust and the variance between them, all of those computation is done by the system to get our material balances. So we can know for I'm just going back to that slide. So we can know that for each of the operations, either the crushing or leaching operation, we can know that this is the output, this is the quantity of HGPLS that has come out, this is the quantity of tailings, this is the quantity of LGPLS that has come out. We can also do analysis based on that, compare that to what came in the mine ore. All of these blue arrows you see going in, these are material quantities that will be maintained, that has to be captured on the system. So everything that is coming out will also be captured. This will be this will be.
So all functionality is available, like in and out at any point we can update our quality checks, and accordingly system can provide the ready like reports from the system we can get.
Yes, we can see that in I have some other slides after all of these quality. I have some slides like okay, these are some of the slides. So we can see that for the different operations, mining operation, grinding operation, based on what we have done, we can see the different quality management. For example, the leaching stage, certain test is done at the leaching stage. Leaching, CD profiling is done. Leaching. At the SX stage, test profiling is done. Extraction stage, during the solvent extraction. Which other one do we have here? For cobalt, for example, when we do a neutralization operation, that's QM06. Filtration test is done like that. So these are what has been done with the previous customer. So like I said, if our own quality management requirement differ, then we will need to update our operation at one point. For example, is it when we transfer to the run pad that we carry out this particular QM test? If no, for us, for Asomika, if we do that at the screening stage, then that will be updated, and the system will set up based on that. So it's not fixed. It's based on our engagement, what has been documented and signed off, that will be built into the system. What we see here is just for us to leverage on it for quick implementation.
Okay.
Okay. I think we were looking at this. We were looking at the overall process as is before we started discussing some questions. Basically, these are graphics to show us. These are all graphics to show us. So let's move on. again, the point to point out here is that I know that we would have some historian systems, some machines, that we use for capturing data. To point out here that integration between those third-party, what we call third-party applications or third-party historian systems, basically, can also happen between them and SAP using we can use a middleware to actually push data from, for example, in the lab, if we capture data of analysis using, for example, our spectrophotometer, for example, the data can be pushed directly into SAP using what we call APIs. But today, because of both of the activities are done in the cloud for SAP, then we can use CPI. So these are just application programming interfaces. The latest one is the cloud programming interface that SAP has provided. So these are standards. So those integrations are possible if we don't want to maintain data in SAP manually. From an integration point of view, that's an interfacing SAP with our existing applications.
Yeah.
The next is from a I think we discussed planning. Okay, we discussed minerals mine ore processing basically, but let's just say some things about it. So it's also possible for us to actually maintain on the system what we call our business plan, the plan in terms of volume or quantity plan. So whatever we agree over a period of time for our sales team to say, over a 1 year period, over a 1.5 year period, this is the target that what we call management target. You can, in the business at Somika, it can be described something else, but what we call management target, we can maintain that on the system once we all agree, and that is actually now sent to the operations team. So there's a functionality on the system that called once those quantities are maintained, if you look at this slide, the ones in blue are the ones that are done on SAP. The ones without this icon are the ones that are done outside of SAP. So this particular task of obtaining the consensus plan is done outside of the system. It entails management, all the stakeholders deciding on the quantities of cobalt and copper that will be produced over a period of time. Once that is socialized with the other stakeholders, is now maintained on the system. This is the first step on the system. It is maintained on the system as what we call planned independent requirements. Planned independent requirement. Then planned independent requirement will be maintained as inactive version. So the system has a functionality to maintain management targets, and inactive version just to have those management target on the system. We now have the active version that is maintained by the operations team, basically based on the capacity of our testing lines. So it might be the same numbers as what was received from management. It could differ. This could be a little bit lower because capacity and all of that has been taken into consideration. So then based on this active version, this is not the active version, the system can now plan to determine for me over the 1 year period what volume of raw materials I need, reagents, or everything I need for that period. And we can now begin to look at how to plan on how to procure all of those externally procured items. That will be done between the production planning team and the main planning team. So what I just explained is what we see here. So for production, basically, it will be planned orders that will be generated. For procurement, it will be purchase requisitions. That's what they use to analyze. That is what is the object that is analyzed on the system. The system generates planned orders as well as purchase requisition. Purchase requisition will be for externally gotten items. Then capacity evaluation, all of that can be done. So this is the planning process that is done. Basically, the point we're trying to drive home here is that we'll have management targets maintained on the system. It will be an inactive version because it's a very ambitious target, you understand? So, but when we now consider capacity, that's not it might reduce a bit. It might be the same or it might reduce a bit. That's when we now have an active version that system looks at and plan using the planning engine on the system, which we call material requirements planning. Now, in the execution proper, that's what we call our minerals processing. I'll go to the next slide. This is one we discussed earlier. So this is the execution proper, what to do on a daily a daily basis. We'll discuss a bit just now about it. We'll create our planned order, our process order for the month, and against this process order, actuals are maintained on the system. So when we release the process order, of course, batch number will be generated. Then against this process order, we'll now begin to enter intervals, what we produce from the mine or what we produce from the sulfuric acid plant. So this particular process covers the cycle in each of our various plants. It's the same cycle. The only thing that will differ is that the materials that we'll be creating our process order, for example, if it's the mine, the output here will be our mine ore. If it's in the sulfuric acid plant, the output here will be our sulfuric acid, QSO4. If it's in the solvent extraction and electrowinning, the output here will be our copper. And of course, once the output differ, the components will also differ based on the bill of material that we maintained earlier on. So this is basically the cycle. So this contains our process order, release the process order. Along the line, if management is activated, inspection lots will be generated automatically. Inspection lot also be generated automatically at the end. This is in-process inspection. This is at the end of production. So at the end of production is when we post our goods receipt, and that's what generates our inspection lots. Then, of course, this transfer of the product of our finished product, that's our sheets, copper sheets, or our powder, cobalt powder, can be done in a two-step or it's in a single step. So for the sake of details, we have maintained it here as two-step. They do it at two steps. The production team initiates by giving it out. If it's the finished product, then the commercial team, they receive it to their own storage location. So this is like an overview of the detailed cycle for the production process. So let's now move on to integration points in all of this our process that this process we highlighted, where the integration. So there's integration that happens with QM, there's integration that happens with MM, and there's integration. When I say MM, I mean inventory management, basically. Procurement, that's MM, SAP materials management. With QM, that's quality management, and with finance. So for us in production planning, what we do is we deal with quantities. So we post goods receipts. The yield, we call it yield. That's yield is output. Basically, for our copper, yield of our copper sheets, yield of our cobalt powder. We post goods receipt for those yields. We also consume whatever has been used up. Material components that have been used up. If it's the finished at the finished goods stage, that will be our KG materials. Whatever goes in is consumed as it has happened physically, is consumed on the system. Now, there's a transaction that we said earlier on. This is consumption of activity types, things like what we call activity types, like our energy or power, our labor, our machine time. We consume all of this also. So these are the three consumptions or three processes that happen as actuals. Now, when this happens, what happens? In terms of goods receipt, the quantity comes into the system. The quantity comes into the system. For goods issue, quantity depletes on the system. And for this quantity increase in the system and quantity depletion, usually automatically what we call a material document is generated to document what has happened. Then for each material document number that is generated, automatically these transactions, an accounting document is also generated. That's how it works. The material document is generated for this to document what are the quantities that has happened in the posting. Then automatically behind the scene, postings happens into the GL. And those are the postings we have highlighted in the here, for example, of these postings, the stock account, all of those postings. That's the setup, based on the setup that will be done in the finance process area. Then we also say the integration with QM, we said that there are two, I think those are the next slide you will see. There are actually two of inspection. You have the in-process inspection, the inspection after production. So in-process is within the process. System S4HANA functionality allows us to actually draw samples, analyze, and record the results. That's in-process inspection. Then There's the goods receipt inspection, that's at the end of production, that's 04. For in process, it is 03. Inspection type 03 for in process. But for, okay, instead of, let me show those slides and try to explain that. So this is in process inspection. It's a inspection type 03. So the system allows us to be able to generate inspection lots while in the process for semi-finished materials in the process while we are processing our ore within the process. Now, also system allows us to record results for after production. 04 after production. 04 is after production. Inspection type 04 is after production. That's what we see here. That's inspection type 04 after production. So what's the difference between 04 and 03? So this controls inventory, this controls stock. So without completion of the cycle of this cycle, that particular stock that we have declared cannot be used for the next step. That's the difference. But for 03, it doesn't control stock. 03 does not control stock. Inspection lot is generated, we go through this cycle. What's the cycle? Again, let me just pause here now and run through the cycle for quality management. So the quality management is that the point of release, remember we said when we release our process orders, a batch numbers will be generated, automatically inspection lot will be generated also. So once the inspection lot is generated, the inspection lot is what the particular item within quality management that will go into record what the result of our analysis in the lab. Then once that is done, we go ahead to evaluate the results. Then if the results are okay, then we'll make a usage decision based on the results we have. So usage decision will be it's fit for the next process, or it's not fit for the next process. It's okay, it's not okay. That's usage decision. For short, we say UD. We'll make a UD based on the results we have recorded for that particular inspection lot. The cycle is actually the same: record result, evaluate the result, stock posting, and UD. The cycle is the same. The only difference between 03 and 04 is that this is for within minerals processing, within the cycle for our semi-finish within. Then, but for 04, it is at the end of production. That 04 controls stock, controls quantity. This does not control quantity. That's just the difference. I'll pause here to take questions on inspection, on quality management, inspection type 03 and 04. So this is 04. If you take note, the steps are the same. The only difference is that at this stage we post stock. You can see we post stock 04. But for 03, there's no posting of stock here. That's the difference. There's no posting of stock. This does not control stock. For 04, we post stock. So this is QM in production, the two types that we have, 04 and 03. Let me now, 03. Now let me now look at QM in procurement. This is QM in procurement. So for procurement, what happens, what generates, what triggers the inspection lot? It is when our colleagues in the warehouse post a goods receipt against purchase order. Now this is not related to a purchase order. This is purchase order. When they post goods receipt for anything that is coming in from being supplied by our suppliers, inspection lot will be automatically generated. So it is this inspection lot that results are recorded for. Of course, samples are taken, analyzed, then whatever results we have recorded, arrived at, will come to the system to record the results. We evaluate the result, and the steps are similar. Same. Evaluate the result and make a usage decision. Is it fit for the next step? We say we post it to unrestricted use. Is it not fit? Then we post to block stock, basically. That's the cycle for quality management. Then there are reports. There are reports on the system, standard reports, analytical reports that comes standard with the SAP system. These are some of the reports that we have on the system. There are operational reports, and of course, reports that help us to financial related reports, production processing, minerals processing related reports, all of those material balancing reports that comes on the system. And also note, if we have any specific reports that we use in the business that is critical, we compare to the thousands of reports that we have on SAP. If we don't see anyone that matches, then we now need to go ahead to come up with a requirement for a custom report. So once the data sits on the system, definitely the report can be gotten. These are examples of reports. Further examples of reports. These are QM related reports, analytical report, and operational report, and all of that. So this is not an exhaustive list. So if we have this slide with us, we will have more to this, but we'll just give some usually frequently used reports that that is being used based on experience by the based on our engagement with previous customers. These are the benefits of implementing SAP production planning within the SAP S/4HANA solution. At this point, I will pause here to take some questions.
So, Prerak and team, any questions?
Yeah,
nothing
no
from my side.
questions.
Sir or Ashwini?
Yeah.
Ashwini?
No, nothing.
Okay. All right, I think it's right on
Ashwini,
time.
anything from your side?
Did you ask me?
Yeah.
Yeah, say any question from your
Yeah,
side?
I'm good. I'm good. I'm good. Okay.
Okay.
So, Prerak Bhai, thank you for joining us, bringing your team. Appreciate it. Also, on our side, Joseph, thank you for covering nicely and right on time. Krishna and team for staying with us throughout the journey. We will come back with another session for the supply chain and the finance. There's a finance session tomorrow. We'll also schedule a supply chain session, source to pay and opportunity to cash as a follow-up. Any other sessions that we need other than the finance and supply chain?
No, if anything, then we can discuss on that once we go through this.
Okay. Awesome. Thank you so much, and you all have a good day.
Yeah, only one
Thank you.
point,
Thank
like,
you.
okay, this, hello.
Yeah, go ahead, Tushar.
Yeah, go on.
Yeah, good.
Sure.
Actually, this on the slides look good, but can you just show on the ERP side, like how it is looks, so that will be good to understand.
Yeah,
Because
so
process-wise,
yeah, I see your point, Tushar. So Joseph, I spoke to Joseph already. Can we show the modeling in the system? You can take some time, Joseph, right?
Yes.
Perhaps next
You want us
week.
to start this
Thursday?
day or the day after?
Yeah, take time till next week, okay? I'll set
just
up another.
mining and production also enough for us to understand, because I know the remaining models are quite standard, and definitely that will fit our requirement. Only we want to understand the how mining and these grade variations and the recovery, metal balancing, all these things, how the SAP will help us in that area particularly.
Okay. So mining. Got it. Yeah. Okay. So we will let you know the date. When can we demonstrate that, Tushar?
Sure. Okay.
But we'll continue with other sessions and come back to the mining system demo.
Yeah,
that's fine.
Yeah.
I think okay then.
Yeah, that's it for now. Then thank you all, Andy and
Okay,
the
thank
team
you.
for.
Thank you,
Thank you
Vision
so much.
Soft team.
Yeah. Thank you. Have a
Thank
good
you,
Thank you.
guys. Thank you. Good day. Bye.
Thanks. Yeah. Bye.